MCT4C, we're doing problems today with more than one right triangle together, and I hope we can have a little bit of fun with this. I'm going to do two examples. The first one, I want to solve for three things for the length of y, theta, and the length of x. And I have a right angle triangle against another right angle triangle. So I can't at this moment solve for x or for theta because in that right angle triangle I don't have enough information. But I can solve for y because y would be the length that is shared with the bottom triangle and the top triangle. And so if I solve it first, I can use it to find the other two pieces of information. So in the bottom triangle, I have an angle, 65 degrees, and I have a length of 23, and I'm going to use that to find y. So in the bottom triangle, my angle of reference is 65. I'm going to mark this side as hypotenuse, this side as opposite, and this side as adjacent. So from the bottom triangle, I am going to use the ratio opposite over hypotenuse sine because I don't care about the adjacent side and I don't know it. So I'm going to use the other two. Sine of 65 degrees equals opposite over hypotenuse, which is 23 over y. I want to solve for y. So I don't want y on the bottom of my ratio, so I'm going to multiply both sides by y. And then I'm going to divide both sides by sine 65. And then I'm going to use my calculator. Come on. 23 divided by sine 65 gives me a length for y of about 25.38. 25.38 is y. So now I can do the top triangle, the one to the right, and solve for x and theta. You can do it in any order you wish because you have that y side and the smaller side of 12. I'm going to solve for theta next. I'm going to label my sides of this triangle. This is the hypotenuse side. 25.38 would be the opposite side, and the adjacent side is 12. So for this right triangle, I am going to set up my trig ratio using adjacent and hypotenuse because I want hypotenuse. I have adjacent. You could hear me falter there, made another boo-boo. If I used adjacent and hypotenuse, I'd have too many things that I didn't know. So I have to use opposite and adjacent. I'm going to use tan because I don't know theta. I'm going to use the 25.38 that I just found, and I'm going to use 12 adjacent. So to find my theta, I have to get rid of tan on both sides by second function tan. 25.38 over 12, and I will type that in my calculator, and about 64.7 degrees. So I have theta. The last thing that I want to find is side x. I have three possibilities to find x. I can use Pythagorean theorem. I can use one of the trig ratios. I could use, I've already used tan, so I could use cos or sine to find it. I'm going to use Pythagorean theorem because we haven't used it for this particular problem. I know that 12 squared plus 25.38 squared equals x squared. My x value, let's do 12 squared, 144, and 25.38 squared. Oddly, I can't do that in my head. Squared is 644.14. So x squared is 644.14 plus 144, 788.14. Square root is 28.1 approximately. I noticed in my notes that when I did it, I used a trig ratio and I got the same answer. It doesn't matter. We found all three pieces of information. Second example. We want to find the length of BC. So B to C is this entire length here. Notice that the triangle ABC, which is where length BC is found, is not a right angle triangle. So at this point, and you know what's coming, but at this point we've only got right angle trig to work with. So we are going to split BC into two parts, y and x. Find them separately, add them together, and we'll have BC. So one part at a time. For the upper triangle, we have 40 degrees and we have a length of 10. So we could find length x by using a trig ratio. So for the upper triangle, I'm going to use my angle of reference 40 to label the sides. This would be the hypotenuse side. This is opposite, and the 10 is adjacent. So since I have the 10 and I want the opposite, I'm going to use the tan ratio to find length x. So tan of 40 degrees equals opposite, which is x, over adjacent, which is 10. To solve for x, I'm going to multiply both sides by 10. So 10 tan 40 equals x. And using my calculator, I get about 8.39 for x. Is that reasonable? Sure it is. It's close to the 10, slightly smaller than, but it makes reasonable sense for the problem. We want to find length of y as well. We have 35-degree angle of reference for that one. We have an adjacent side of 10, an opposite side of y, and a hypotenuse side of don't know, don't care. So I'm going to use the tan of that one as well. Tan of 35 degrees is opposite over adjacent, which is y over 10. So y is 10 tan 35. 10 tan 35 is approximately 7. So my length of BC, which we tend to write like that, is 7 and 8.39, approximately 15.39. Page 13 and 14, got a slew of them for you. They're nice and easy and fun.